In this video, we're going to cover quantitative reasoning in parts. The same first 7 steps apply for all application questions, which is to read the whole question, draw a picture or diagram, assign variables to the unknowns, translate to an equation, solve the equation, and then check that your answer makes sense, and then finally state the answer clearly with appropriate units. So the uniqueness of this project is talking about how there's usually a lot of different ways you can identify a strategy to move forward to solve for the unknown, and sometimes this requires lots of steps. Sometimes shapes are not obvious at the beginning or they're implied, but understanding the context and drawing a picture or diagram is required to find the answer to a complex question. So this first example gives us a type of scenario where it's not necessarily straightforward. A family wants to build a fence for their new puppy using 6-foot fencing panels from the Home Depot. The cost of each panel is $144. They have saved up $2,600 to build the fence to enclose the rectangular part of the backyard. They'll use the entire 48-foot long back of the house as one side of the fence. What are the dimensions of the enclosed space they can afford to enclose with the fence panels, assuming they cannot buy partial panels? So in this scenario, I want to draw the side of the house. And this house is going to be 48 feet. Since it says that the cost for each panel is $144 and they've saved a total of $2,600 to build the fence, we know that some amount of fencing along each side will be equal, and we know they have to go all the way across this 48 feet, but they only need these sides and the back of the yard to totally enclose the backyard for the puppy. So we know that the 48 feet have to be there. So let's figure out how many panels that would be. If we took 48 feet and we divided it by 6-foot panels, that would give us 8 panels. So we know we have to have 8 panels for the back. Now let's list our information. Cost per panel is $144. Total budget is $2,600. And we need to figure out how many panels we can afford for the sides, and we don't know how many that would be. So we can say our unknown is total panels. If that's the case, we can say that's an X because we want to know how many panels that is. So we can write an equation as $144 times the number of panels we can afford has to be equal to $2,600. And then we can just divide both sides by the 144 to see how many full panels we can get. If we divide by 144 on both sides, our answer comes out to 18 whole panels. because remember, we can't afford partials, or we can't buy partials. So if we know we need 8 for the back of the property, then that leaves us 10 remaining. And to keep this as a rectangular shape, we'd have to divide this by the two sides so that we have an equal number of panels on each side. So that would give us 5 panels per side. And so the dimensions of our enclosure would be 5 panels, or 5 times 6 feet, which is equal to 30 feet. So each side will be 30 feet and the back will be 48. So the dimensions of the enclosed space are 30 feet by 48 feet. A high-end custom in-ground pool costs $125 per square foot. The depth is usually not part of this calculation since it's an estimate and people usually choose to go with a certain depth for a backyard pool. We need to estimate the maximum pool area you could afford for a circular in-ground pool, given you planned and saved $55,000 for this renovation. Round your dimensions to the nearest whole number. And then it asks for the radius and diameter of the pool. Since we know the area of a circle is equal to pi r squared, and we know that area is what we're trying to figure out, but we have a maximum budget, we could figure out how many square feet total we need first. So if we say $125 times the number of square feet equals $55,000, we could isolate the x by dividing by $125 to see how many feet we can afford. When we do this, we get approximately 440 square feet that we can afford. So if we know that's the case, we can use our area of a circle formula and we can replace the area with 440, and that's equal to pi r squared. So now if we divide by pi on both sides, we get 140.06. Now remember, this is equal to r squared, so this is not our final answer. We have to take the square root of both sides, and this gives us r is equal to 12 feet. So if the radius is 12 feet, the diameter is double that, and so the diameter is 24 feet.